Welcome back to DIY My Way. When I've worked on projects in the past that involve metal, I've either had to use my chop saw to cut metal or a right angle grinder with a cutoff wheel. I've always envied the folks on YouTube channels that had plasma cutters, and so finally I've had an opportunity to get one from Vevor. Vevor sells a vast collection of products across many categories, including welding, which includes plasma cutters. The Vevor CUT50P is a 50 amp non-touch pilot arc dual voltage plasma cutter. The key specifications are summarized nicely in this graphic I borrowed from their website. The unit weighs 23 pounds and is fairly compact as the dimensions show. The electrical specs seem reasonable with one exception. I don't know about your neck of the woods, but in mine there's no such thing as a 40 amp 110 volt outlet, as becomes apparent in the testing coming up. It has a high-frequency pilot arc feature to ignite the plasma, so you don't have to scratch start it against the material to be cut. It can clean cut up to a 1/2 inch thick mild steel, with a maximum severance cut of 5/8 inches. The duty cycle is 30% at 50 amps, 60% at 33 amps, and 100% at 25 amps. And it can cut aluminum, stainless steel, mild steel, and copper. Also, it uses IGBT inverter technology and has a 1-year warranty. Besides the plasma cutter itself, the accessories include an AG60 torch with over 16 feet of hose. Looks like it's cold and ready to strike if you come too close. There's also 2 extra sets of nozzles. It also comes with a ground clamp with 6.5 feet of cable. Sure would have been nice if it had been 16 feet long too. There's a pressure regulator and a water separator and various pieces for connecting it up. They even throw in a roll of Teflon tape. There's almost 10 feet of air hose, of which only a few inches are needed. And finally, there is a 220 volt to 120 volt adapter. The CUT50P is currently priced at $234.99 on their website and on Amazon. However, they've given me a 5% discount code you can use on their website, which you'll find in the video description along with links to the CUT50P on their website and on Amazon. So let's open up the box and see what we have. I'll spare you the real-time unboxing by speeding the video up 10 times, but I will say that it is well packaged. Before I can use the plasma cutter, I have to assemble and install the pressure regulator. The inlet is on this side and the outlet is on the other side, and the pressure gauge goes here. Instead of using their barbed hose connector, I'll use a standard male quick connector on the inlet side. The threads are already pre-treated with pipe dope, so all I have to do is screw it in and tighten. Now for the outlet side. Their Teflon tape seems too wide, so I'll use mine. Next, the gauges go on. Unfortunately, the gauge is in megapascals and kilograms per square inch instead of PSI. There are 2 threaded studs with nuts and washers on the back for mounting the regulator. The hose fits pretty loosely on the barbed connector, so I'm not sure it will be airtight when clamped on. The hose fit on the plasma cutter connector isn't much better. I cut a few inches off the hose, then clamp one end down. and then the other. I turn on my compressor to get it filling up while I move the plasma cutter to the welding table. You hear that? That's the sound of a leak. And I believe it's around this fitting right here, which I had read in some of the reviews, some of the other online videos, that that's a problem because this is not a tight fitting. I'm going to see if I can fix that somehow. Some of the provided wide Teflon tape might do the trick. And it's still leaking somewhere. Oh, down here now. All right. I think I fixed it up here, but it's leaking down there. So we'll do the same thing. I don't hear any leaks. That's good. We'll start it off on 110 volts and see how it performs. Since the pressure gauge is not in PSI, I'll use my handy-dandy units conversion program. The manual says to set the pressure to 4.5 PSI, which is absurdly wrong. 45 PSI seems more likely, so I'll start there. That translates to 0.31 megapascals, so let's dial that in. By the way, I've set the compressor to 90 PSI. Okay, it's time to hook up the torch and the ground leads. Ground lead connects here. The ground clamp is very basic, but it does have copper contacts with a braided connector between them, so I do like that. The positive torch air connection screws on next. It just needs to be hand tight. Next, the pilot arc connection, which is the red wire. And finally, the trigger control connection pushes on, then has a screw-on collar to secure it. All right, let's turn this thing on. It's a fairly quiet unit while running. The controls are about as simple as it gets. There's an amperage display, a power indicator, an overheat indicator, and an amperage control knob. Let's see if the torch works. It does. To start with, I'm going to try cutting through this 24 gauge siding that was left over from building my shop. When plasma cutting, you need some certain safety gear, respirator being one of the things that's recommended. I got this 3M model along with some filters recommended for this. So I may not sound very clear. I'll be able to understand me at all. If that's the case, I'll just narrate over the top of it. And shade 5 glasses. You can use a welding helmet. I will try that, set to shade 5, but let's do this first. And gloves. Curious to see how this is going to go. I attach the ground clamp to the piece of siding. The current is set to minimum, which is 21.2 amps. Well, it's cutting the sheet metal easily, but the torch is going out at times, and the pilot arc seems to be interfering with the wireless mic. This is probably due to a poor ground connection through the siding paint. Bear in mind, I'm just playing here to get a feel for it, and not practicing good technique.
Beautiful, huh? My first cuts with a plasma torch.
Next, I'll try cutting some 14 gauge base angle, also left over from the shop build, keeping the amperage at minimum. The sparks flying upward instead of through the metal indicate I'm not cutting all the way through. This means I'm moving too fast or I need to crank up the amperage, so I turn it up to 30 amps. It's doing better, but I still haven't cut all the way through. Once more with feeling. There, it cut through. I start a second cut, and then it happens. Watch the amperage display.
Yep, I blew the breaker, the 20 amp breaker on a dedicated circuit. Of course, I was running at 30 amps, but presumably at a lower voltage, so I'm just going to go ahead and switch it over to 220 and we'll see how we do. There we go. All right, let's have a go at 220. I'll also bring you in closer so you can see what I'm trying to do.
A smooth constant speed is key to a clean cut, and I'm clearly not there yet, but I can tell it's performing better on 220 volts. Okay, that was my best cut yet. I'll just zip these off and then on to something thicker. Next, I'll try my hand at cutting 3/16 inch mild steel at about 41 amps. Needs just a little bit more. There we go. Let's try that again at a maximum of 50 amps. That went better. There's a little bit of dross on the cutting edge, but that's easily remedied with a chipping hammer, just like with welding slack. Now let's try cutting 1/4 inch mild steel at 50 amps. First cut, not so great, but most likely my fault as a newbie. I'll try again. Now that looks better. Just need to knock off the dross. Those diagonal lines are caused by my inconsistent travel speed. The more consistent the travel speed, the smoother the cut.
We interrupt this program to bring you an interruption in the program. I had another air leak here develop, so I'm about to do something a little different because the bottom line is these barbed connectors are too small for this hose, or the hose are too big for the barbed connectors. But honestly, there's almost no barbs on these things, so I'm going to try something else. I'm going to try another one of these connectors, quick connector. I think the hose will fit just over that. And maybe we'll have better luck. Let's find out. That's about as far as that thing wants to go, so I'm not going to push it any further. I can just force this hose over that barb. Should put a little Vaseline on it. That'd have been a smart thing to do. Let's see if that holds. See what that does for us. And it's still leaking. It's leaking somewhere. Oh, down here this time.
Maybe a little more Teflon tape will fix it.
The sound of silence. I'm not hearing any leaks. Good. We'll continue cutting.
For my final trick, I'm going to try cutting 3/8" mild steel at 50 amps because that's the thickest metal I have on hand. Clearly I need a lot more practice, but the plasma cutter did cut it. In case you're wondering, the plasma cutter makes a mess on the floor and is spewing molten metal droplets, so be mindful where you do your plasma cutting and where your feet are.
One thing I've learned is just like welding, plasma cutting is fun. And I want to thank Vevor for providing me with the CUT50P. I think it's an excellent addition to my tool collection. And I'm going to get to learn a new skill. It'll just take practice. I hope you found this video helpful, and if you did, please click that like button, leave a comment, and by all means, please subscribe. If you want to know when I post new videos, click that little bell. As always, thank you for watching, and I'll see you on the next one.